the largest and most massive object that emits a tremendous amount of energy. From the center of our solar system, where no one can ever reach, the Sun. Is just one of the billions of such stars in the entire Milky Way galaxy, although it's a special star for our solar system. With a radius of 695,508 kilometers, our Sun is 150 million kilometers from Earth. And its volume would require 1.3 million Earths to fill it. Our Sun is located in a spiral arm called the Orion Spur of the Milky Way galaxy, around 2,600 light-years from the middle of the Milky Way galaxy. The Milky Way galaxy is the name for the galaxy that formed our solar system. Our Sun orbits the center of the Milky Way galaxy, bringing the whole solar system along with it. Generally, it takes about 230 million years to make one complete orbit around the Milky Way galaxy. Our Sun is a blazing hot ball of gas that's rich in hydrogen and helium. According to the scientific data obtained through the analysis of numerous such atoms, it is made up of 91% hydrogen and 8.9% helium. The Sun produces light energy by a reaction called nuclear fusion that converts hydrogen into helium in its flaming core. A hydrogen nucleus consists of a single proton, while the helium nucleus contains 2 protons and 2 neutrons. Normally, protons have a positive electric charge, and they repel each other because of similar charges. But in the core of the Sun, which has a tremendous pressure and a temperature, which reaches up to 15 million degrees Celsius, the extreme conditions are strong enough for the fusion process to take place. The overall consequence of this reaction is that 4 protons are combined to form 1 helium nucleus. During this reaction, 2 of the protons turn into neutrons via the weak nuclear force. The mass of the final result is slightly lower than the mass of the 4 protons that came together. The difference between these masses is converted into energy in the form of heat and light that exists in the sun. Every second, in the core of the sun, over 4 million tons of matter is converted into energy by these reactions, thus giving an immortal life to our sun. The sun has 6 layers: the core, the radiative zone, the convection zone, photosphere, the chromosphere, and the corona. At the core, the temperature is as high as raging 15 million degrees Celsius. This is the place where the sun generates all of its energy by the happening of the nuclear fusion reactions. The radiative zone, its name is derived from the manner in which energy is transferred outward through this layer. The energy, generated by nuclear fusion in the core, moves through this layer in the form of electromagnetic radiation. The convection zone is also named after the manner of energy flow in this layer. In this layer, heat and energy are carried outward along with matter via rolling convection. This motion is like the rolling flows seen in a pot of boiling water. In this layer, temperature drops from 2 million Kelvin to 5800 Kelvin. The energy produced in the core takes as long as 170,000 years to get from the core to the top of the convection zone. The photosphere. This is the visible surface of the sun. The temperature is about 5,500 degrees Celsius. This is the region where sunspots are found. Although the temperature of this layer is about 5,500 degrees Celsius, the temperature at the sunspots is about 3,800 Celsius. That is the reason why we see them in dark. Our sun is covered by gases called the solar atmosphere. It is so hot that the gas here primarily exists in a plasma state. The lower region of the solar atmosphere is called the chromosphere, and the topmost portion of the atmosphere is called the corona. These top regions of the sun are usually so dim to be seen against the brighter photosphere. But during a total solar eclipse, the moon covers and blocks out the bright light of the sun. When this happens, the chromosphere can be seen as a red rim around the sun, while the corona forms a glowing area around the eclipsed sun. The plasma in the chromosphere is about 10 million times less dense than the surface of the sun. This low density makes the corona much less luminous than the surface of the sun. But the temperature in the corona is about 2 million degrees Fahrenheit. It's a little intriguing for the scientists until now. The corona is the outer layer of the sun, but it is hundreds of times hotter than the sun's surface. Our sun has a giant and complex magnetic field. Scientists believe that the sun's magnetic field is generated by the flow of hot, ionized gases in the sun's convection zone. As the sun's magnetic field actively moves through the sun, some areas appear in dark, called sunspots, on the surface of the sun. Sunspots can be fairly large, with their diameters being as large as 50,000 kilometers. These sunspots are created by disturbances in the sun's magnetic field. Sometimes, the larger sunspots can be seen from the Earth without requiring the aid of a telescope. But they may travel of a few hundred meters per second when they first emerge. You have probably heard of a solar wind. It is a flow of energetic particles, such as electrons, protons, and atomic nuclei, like helium, that comes off the upper atmosphere of the sun at about 1 million miles per hour. And they travel throughout the solar system in every direction. These particles can escape the sun's gravity because they are so hot that the sun's gravity can't hold them. Our sun now is around 4.5 billion years old. According to scientists, the lifetime of stars like our sun remains about 9 or 10 billion years. So our sun is about halfway through its life. By the end of the life of our sun, it will become a red giant, which will become about 2,000 times brighter than what it is now. The hydrogen in the core will deplete, leaving an abundance of helium. By that time, the forces of gravity will take over. It will become so big that the closest planets will be eaten away. And eventually, the sun will shrink into a white dwarf. But by that time, not just the sun, but many other things as well, will be ruined. That includes all the living things on the planet Earth, including the Earth.